So you just started calculus and you want to know what the heck is a limit? Kind of the first new topic that calculus throws at you here. Well, to talk about what a limit is, let's first kind of understand that a lot of what you're going to do in calculus is really going to be split, sort of an extension of what you learned in algebra and kind of this new world of calculus and how they sort of extend ideas that you're already very familiar with. So back in algebra, we had what were called function values. A lot of times, most people just called them y values. So I could walk up to you right now and say something like f of 3 equals. And so what I'm looking for is I'm saying, okay, I'm giving you this x value right here, and I really want to know what the y value is that goes with it. Well, if you've got a graph, something that looks like this and this cuts through like that, to find out where that y value is, you'd go over and you'd say, okay, well, when x equals 3, my y value maybe equals 5. And so the function value, what I call the dot on the graph, would be at 5. You can also have a situation in algebra, right, where somebody might come up to you and say, okay, well, what's f of 3 equal again? And this time the graph, as it comes through, maybe has an open circle sitting there at 3. So you still do the same game. You'd come here and you'd say, okay, when x equals 3, it looks like, oh, I've got an open circle. There's no dot on the graph there. So that would be an undefined situation. There is no y value. So calculus comes along and it introduces us to this new idea of a limit. And so you get notation that looks now like limit as x approaches 3. So again, we're talking about an x value there of some equation. And again, what we're looking to find out of here is we're looking to find a y value. Well, the cool thing about limits is they just want to know what does it look like you're headed towards. So we could have sort of that same graph we started with, that original graph, where we'd say, okay, well, at 3 again, 1, 2, 3, what does it look like my graph is headed towards at this position here? So I'd be looking as it heads towards that point, what does it look like I'm headed towards? Well, in this situation, the dot's there, it's headed to 5. That's the same as we saw in the other one. What makes limits really kind of cool again is that they actually don't care if there's a dot there or not. So if I'm asking you the same exact question and we're looking at a graph that looks like this second graph here, so we come through and we've got this open circle sitting right there, and again we'd say, okay, well, at x equals 3, what does it look like I'm headed towards? Well, the graph looks like it's headed towards that same place. It still looks like it's heading towards 5. And when you're talking about a limit, that's still the answer. The limit doesn't care if there's a dot there or not. A limit just cares what does it look like I'm headed towards. That's kind of the new idea, the nuance behind a limit.